Okay, this is the video solution for assignment number 8. And please make sure you read the description here carefully, but I'll go through it with you. So we have an object like that, and you're told that the top of this cylindrical protrusion is clamped, and a total force of 5,000 pounds is put on on the edges of these holes. Uh, First of all, you're supposed to use as many planes of symmetry that you have, if any. In other words, take the smallest unit of this problem that you can analyze in order to know the whole story in the structure. In this particular problem, by the way, if you think about it, most people will probably take a quarter of that. But as a matter of fact, that is not the smallest portion. If you take 1/8 of this model, and you repeat it 8 times around it, you basically have the knowledge of the entire stress distribution and displacement of the structure. So it's 1/8. And then, of course, it also says use the default element size, linear element, default element size, but perform local mesh refinement on any holes that are going to be remaining, on any curved surfaces that are going to be remaining, okay? So in this particular problem, if you do 1/8 of that, the only thing that's going to be refined is half of that uh, curved surface that you see here, okay? And yeah, so that's what I mean by these last two lines, 3 lines. And I'm saying if it's not clear, watch the video. Obviously, you are watching the video. Okay, anything else here we have to know? No, let's move on. Oh, by the way, because you know what you're dealing with, 1/8 of this model, you have two choices. Make the 1/8 of the model, that's one option, or make the whole model and then cut it with the appropriate planes to recover that 1/8 of the structure. Now, I know that sounds crazy because it looks like we know what we're doing, but we're going to make the whole thing and then start cutting it so that we end up with that 1/8. But that's how I'm going to do that so that you have some detour or some revisiting of the concepts that we have done. Okay, so let's go ahead and do that. We start with the part file. I'm going to call it homework 8. Homework 8. Say OK. Immediately I'm going to save it. File, save management, save as. Here I'm going to make a folder. I'm going to call it homework 8. CAD. And everything is going to go into that folder. Okay. So on that vertical plane, I will sketch a square of the dimensions that are given in the description of the problem, which happens to be 6 inches by 6 inches. So this is 6 inches. You were told that the units are imperial units, so this is 6. And this is 6. Okay, good. And you have a choice of making the holes right here or making a pocket and then using a circular pattern. That's entirely up to you. Entirely up to you. So what I'm going to do is the following. I will actually make the holes right here. Okay. So let me make a circle. We're going to position it properly. Now the distance from the center to that axis is actually, by the look of it, is the diameter 0.5. The diameter is 0.5. That means the distance from here to here is 0.25. Okay? I'm sorry. Sorry. Let me see now. This dashed curve, dash circle, diameter of 4, radius of 2. So that's what I meant, 2. Okay, so let's go here, back here. The distance from that to this is going to be 2 inches. Okay. And the diameter of this circle is 0.5 in the drawing it's shown to you. So the radius is going to be, if you're using radius, 0.25. But anyway, radius, yeah, radius of 0.25. There we are. Except that it's not supposed to be there, it's supposed to be down there. So I'm going to bring this thing and put it there. Yeah. Where is it? Coincided with that. So there, that's what I should have done. Okay, so now I'm going to start uh, mirroring this. So for example, let me do the following. We'll do a mirror of that circle with respect to this. No problem. Now I want to take this thing and put it up there. Okay, so there may be different ways of doing it, but let me see if I can use uh, for example, we can use rotate. Let me see. See now. So let's say we make, yeah, that's fine. Try let's try to do this rotation because we have to read this thing carefully. Select the geometry to be rotated. This guy. And it says then select or click the rotation center, and there's the rotation center. Okay, and then select the point to define the reference line angle. So let me, okay, you see this? Good. You really have to, this rotation thing is not as intuitive as it should be. So one has to read the bottom left corner and make sure that you know what you're doing. Now we're going to mirror this fellow. Mirror this with respect to that. Okay, that takes care of everything. Okay, we have a hole here that goes all the way through. If you look at that cylinder, if you look at this drawing, look at this drawing. Where's the drawing here? Uh, See, this hole goes all the way down. And how are we going to do this thing? Now, what we can do this kind of a thing later on. Or I can actually do it right here. Diameter is 1.25. So let me go here. Let me draw a circle here. I mean, there's so many different ways of doing these things that you have to decide on a strategy. So the diameter 1.25, 1.25, 25, and say okay, and exit, and then pad the whole thing by 1.5, by 1.5. That's this thing, 1.5. Okay. Good. Okay. So let's go 1.5. Add it by 1.5. Okay, good. Now the other thing that's not quite clear is see this height here. Uh, 1.5 of it is there, and this whole thing is 4.5. So that means that this cylinder is 3 inches long. Okay, 3 plus 1.5 is 4.5 that you see there. So here's what I'm going to do. On that face, I will sketch. Two things. One of them is going to be that circle, but why don't I project that? There we are. And then I'm going to draw a circle of let's see now, diameter 2.25. It's right here, 2.25. So let's go do that. Normal view, another circle 2.25, diameter 2.25. Yeah, 2.25. And then say OK and exit and pad that sketch up by 3 inches. Okay. So what you see there is, unless I read one of these dimensions by mistake, is what you see over here. Okay. Now I know it's crazy, but I'm going to start cutting it so they get 1/8 of the model. The question is, what is the easiest way of doing that? There are many ways, but here's the easiest way perhaps. On that face, see that? On that face, I will sketch. I'll sketch uh, maybe a line like this, going from here to here, 45-degree angle basically later on. And another one from, let me move this thing further down, right there. We'll clean it up. Another line from here to here. Okay. Make sure this angle is 45 degrees between the angle between something is selected there. The angle between this line and that line. Control Z. Try it again. Angle between this line and this line is easier to pick it from there. Yep, 45 degrees. Okay, you might say, why are you doing this thing? Because what I want to do is I want to create a surface going up and down and then cut this three-dimensional piece with that surface. So how do we make a surface? You have to go to mechanical design, wireframe and surface design. That's one option. Or generative shape design, generative shape design. It's entirely up to you. So it doesn't matter. I'll go to wireframe and surface design. And here's an extrude. Shoot that thing, and down below we say OK, because we're going to cut that three-dimensional object with this surface. We can't cut here because here you can cut only surfaces. So what I'm going to do is back to part design, get the saw, find your saw, read it carefully. Splitting element is this surface, but which side do you want to keep? Not the outside. So flip the arrows, just keep the inside. There we are. Hide this. You could have done this thing from the very beginning. Be my guest. No problem. Let me hide these sketches. That's it. So this is 1/8 of whatever you got. Now this is made out of steel. So why don't we go ahead and apply properties of steel on it? Okay, very good. Okay. And now we're going to go to analysis and simulation, generative structure analysis. We are doing a static analysis. I don't like this rendering. I'm going to change the rendering here. Oops, rendering here. Very good. We know that the top is clamped. That's what you're told. And we know that this is a plane of symmetry and that is a plane of symmetry because you remember you cut it, right? Plane of symmetries, you cannot just leave alone. You have to put some kind of restraint on it. It's a roller or surface slider. So it's this guy, that guy, turn it around, and this whole thing is going to be picked. I mean, when I selected this, the whole thing was picked, but there, because there was a kind of a break between, I had to do them both. Very good. Now the load. The load, you're told a force of 5,000 on each, total of 5,000, right? Total 5,000 pound on the four, four edges of the circles. Now, because we're taking not even one edge, we're taking half an edge. We have to divide this thing by 8 and put it there. Okay, so let's go back here. So we're going to apply a force on that edge. See that? On that edge, in the downward direction, negative 5,000 divided by 8. 4 holes, half a circle, 625. Good. The only thing that I forgot to do was to do local mesh refinement on the hole. So how do I do local mesh refinement? Let me remind you. You go to the model manager, second icon. Actually, there's this collection of icons there. There's a sub toolbar. This says local mesh size. You select it. You select that curved surface. And I said use half of this, whatever it is. Now, if you don't know what it is, cancel that. Double click Double click on this, extend the nodes and elements branch. Double click on that. It says the size that was used by Catia is 0.282. Half of that is 141. Okay, back there. Oh, by the way, it says linear, right? Use linear, not parabolic. That was in the description of the problem. So click on that, click that surface, and you use uh, 0.141. And then we say, okay, you can see what happened here is the half of that essentially. And now if you want to look at the mesh, we'll save this thing first. File, save management, analysis, save as in that same folder, homework 8. I'll call it homework 8 here so that I remember in case things get mixed up. I know what that thing is. All right. And now we're going to run. Ignore that warning because when you put surface slider, it gives you that warning. I'm not sure why they don't take it away. And that is it. So look at the deflection like that. That does not surprise you. If you animate, you can see what happened. These side faces remain flat because they're planes of symmetry. But this thing obviously stretches. If you want to know the displacement, you click on it. It's a very tiny displacement here. 0.0, this maximum is 0.0003. That's obviously because this is, I don't know, this is a 2-inch piece of steel, thick piece of steel. Okay, if you double click on this, you can change the rendering to average ISO and change it to material shading. It looks like that. Okay, and if you want to see the von Mises stress, right there. Now, this is the way I'm doing it is it gives you a big stress around the edges. That should not surprise you because how can you put 600 pounds on a line? That's why you expect a large stress there. But that large stress is not realistic because it's just like trying to take a knife and putting the knife there and standing on it or something like that. 5 people standing on it. Anyway, easy to generate good looking garbage, but we're not showing you the assessment of the quality of this thing. Uh, Incidentally, if you want to change the shading here, double click on this, select these 3 dots and say, don't show it to me as a smooth contour, show it to me as distinct colors. You can see that. And one last thing, if you want to see your elements, anything that you don't like, you can hide. You can hide these, you can hide the load, you can hide that fellow, okay? You can hide the clamp up there. I'll leave the clamp up there so you can see what's going on. But if you go to the rendering here, the very last one, when you click on it, edges and points were checked, so it will be checked so you can see that. Now, I will not bet my money on this because you cannot just simply do an analysis and say, here it is. You have to do mesh conversion study, etc. And we are not doing it in this course. Okay, folks? So that takes care of this particular problem. Please make sure you show up between 7 and 8 on March 12th to show your GAs the work. That is the only time slot that they're going to be there. I will not be around on March 12th, but I have already posted the activities that I would have done if I was there. They're all posted, but keep in mind the GAs are going to be on duty 7 to 8 on March 12th, and that's it. Okay, if you don't show up in that time slot, then that assignment is not going to count. All right, good luck.